So x and y belong to the same coset. Alright, let's use part 2. Okay? So let's just concentrate on one of these two elements. So if x belongs to a coset, you have that coset is of this form, xh. Right? Now so x belongs to A, let's say, coset A, okay? And y also belongs to A. Right? We're told the right hand side says x and y, these two elements of G, belong to the same coset. So let that coset be A, so x belongs to A and y belongs to A. Okay? X belongs to this coset A. Now this is an if and only, if it goes both ways, right? So if x belongs to coset A is xh. So from this, you know that A equals xh. And similar reasoning here, A equals yh. A equals xh. Alright? Now since these two A's are the same, that means xh equals yh. So that implies that xh equals yh. Right? So we have proven the left-hand side. So we've gone from right to left. Now it just remains to go the other way. Alright, so now so we start now with this. So for part 3, we're going from left to right now. So this will be the only if part. Now xh is equal to yh. Alright. Now we can use part 1, right? So if that's true, now part 1 is an if and only if, so it goes both ways. So if this is true, that's true, right? So if we're told this, so we can put this into here and deduce. So from this we know that x inverse y belongs to h. Right? So now if that's true, x inverse y must be equal to some h. Right? This belongs to the subset, so it must be equal to some member of your subgroup. Call it h. Right? So x inverse y is h. Right? So you can rewrite this then as y equals xh. Right? Just take the x, pre-multiply by x, so you get y equals xh. Alright, so that means that y must belong to this, right? If y equals of that form, y must belong to the left coset xh, because it's of this form, okay? Right, so we know that, and okay, so we've got that f. Y belongs to this left coset xh, and where now when x so x belongs to xh. X belongs to xh. Yeah, yes, we know that that's true because h contains the unit element. So we have this, right? Now put those two together, that means that both, so that implies using this and this, so x and y belong to x of h. In other words, x and y belong to the same coset. So we're going from left to right. That's the only if form. Okay. So that means x and y belong to the same coset. So we've done all three, right? Yeah, like I say, quite a bit of dense reasoning. So I'll stop here. Now for the next session, I will show, let's see, what will I show? I will show that a group can be partitioned into cosets. That's a very important ingredient in the proof of Lagrange. So remember what to partition means? By analogy, like if I take my samurai sword and I have a large watermelon, and I just slice the watermelon into parts, and the sum of those parts still gives you the whole watermelon. So a partition, like if you, here's your set in terms of the Venn diagram. If I slice it like that, then that's to partition a set. So every member of your set, call it S. So every member of your set will belong to one and only one of these subsets, right? And the union of the subsets gives you the set, right? So that's what's meant to partition. So each subset is disjoint, and that means each subset has no members in common. Right? They're disjoint. That's what it means. Okay, so that's the concept of to partition a set. So what I'll show next session is the idea that these cosets partition the group, and that in turn is a vital ingredient in the proof of Lagrange's theorem. So I'll stop here for a minute.